Hello, welcome to another episode of our mathematics class. We have the topic on the board which says differentiation, and the question is there for us to solve. Let's solve this question. Using the general method and the first principle method, differentiate. Question number 1, y equal to x raised to the power 3, and question number 2, y equal to 1 over x. Solution. It says that we are going to use two methods here. The first method is general method to solve it, and the second one, first principle method to solve this number 1 case. So let's start with number 1a. Y equal to x raised to the power 3, and we are going to use the general method to do this. The idea behind general method is that we are going to use the power to multiply the base and subtract 1 from the power. So it will be dy over dx equal to 3 times the base, which is x raised to the power 3. Subtract 1 from it, we are going to have our dy over dx to be 3x. 3 minus 1 is 2, 3x squared. So this is our answer if we use general method of differentiation to solve this problem. Still on 1, we call it b. 1b, we have y equal to x raised to the power 3. So this time around, we are going to use the first principle method of differentiation to solve it. The idea behind first principle method says to y, add change in y. So we have y plus change in y, and to x, add change in x. So equal to x plus change in x, all raised to the power 3. Using Pascal triangle to expand this, we are going to get y plus change in y equal to, this becomes x cubed plus 3x squared change in x plus 3x change in x all squared plus change in x all cubed. So it's time for us to transpose our y over to this side. We are going to have only change in y remaining on the left hand side. So we are going to obtain change in y equal to x raised to the power 3 plus 3x squared change in x plus 3x change in x all squared plus change in x all cubed minus y. Alright, recall that y equal to x raised to the power 3. So we are going to substitute for y using x raised to the power 3. So remove it and put x raised to the power 3. We write this, we have change in y equal to x raised to the power 3 plus 3x squared change in x plus 3x change in x all squared plus change in x all cubed minus x raised to the power 3. So we have x raised to the power 3 minus x raised to the power 3. So both will go away. So we have change in y equal to 3x squared change in x plus 3x change in x all squared plus change in x all cubed. Okay, this is what is left. Divide through by change in x. So when that happens, we have change in y divided by change in x equal to 3x squared change in x divided by change in x. Okay? Plus 3x change in x all squared divided by change in x plus change in x all cubed divided by change in x. Okay, so when that happens, this change in x cancels out this change in x cancels out 2, this change in x cancels out, remains what? 2. So our change in y over change in x will be 3x squared plus 3x change in x plus change in x all squared. Okay, we are going to take limits as change in x tends towards 0. If we have change in x still remaining in this, we are going to take the limit of change in x as it tends to 0 so that we can get rid of these. So this becomes change in y over change in x. Taking limit as x tends towards 0, we have 3x squared. There's no change in x there, so it's alone, plus this will be 3x times change in x tends to 0, and this becomes plus change in x tends to 0, it will now be 0 squared. Okay, at the end we have that our changing y over changing x is equal to what? This 3x times 0 is 0, this is 0 already, so what is remaining is 3x squared. So this becomes our answer. If you look at what we obtained here, using first principle method, 3x squared, when we differentiated that function, and what we obtained here, you will see that they are the same thing. So that is the idea of what we're talking about, using general method and first principle method of differentiation to differentiate that function of number 1. So let's go over to number 2. Alright, number 2, the function given to us says y equal to 1 over x. We're going to use the general method first. So let's call it 2a. Before I can solve this, let me write the index form. It will be y equal to x raised to power negative 1. So the idea of general method is we are going to use the power to multiply the base and subtract 1 from the power. So it will be dy over dx equal to, the power is negative 1. Negative 1 times x raised to power negative 1 minus 1. Okay, so our dy over dx will be negative 1 times x will give us negative x. Okay, raised to power negative 2. So at the end, our dy over dx will be negative 1 over x raised to power 2. So our answer is negative 1 over x raised to power 2. Alright, we are going to use the first principle method of differentiation to differentiate that function, and we call it 2b. So let's solve 2b this side. Okay, we have our 2b. The function is y equal to 1 over x, and we are about to use the first principle method. The idea behind first principle method says to y add changing y and to x add changing x. So this will be y plus changing y equal to 1 over x plus changing x. Okay, so this is what we are going to get. After this, we transpose y over to this side, it becomes negative y. So we are going to have changing y equal to 1 over x plus changing x minus y. Recall that y is equal to 1 over x. Okay, so we're going to substitute 1 over x for y here. So rewrite this, changing y equal to 1 over x plus changing x minus 1 over x. So this is where we are. Next is to get the LCD of the denominators. So we have changing y equal to, LCD of the denominators will be x multiply what? X plus changing x. Okay, so when x plus changing x divides this, we are going to have x remaining. So x times 1 is x minus bracket open. X divided this will give us x plus changing x times 1, we have x plus change in x. Okay, so our changing y will be x negative 1 times this will give us negative x times this will give us negative change in x all over x bracket open x plus changing x bracket closes. So having reached this extent, let us erase this part of the board to complete our task. Okay, hope you are getting what we are doing today. If you are finding any step difficult, pause and go through it over again. If you have a question, drop it in the comment section and I will see it later. Okay, we continue with the solving. So having gotten this far, we can observe that x minus x will go away. We have our changing y to be equal to negative changing x all over x. Open up the bracket now. X times x will give us x squared. X times this will give us plus x changing x. So this is what we're going to get. What we are going to do now is as easy as ABC. What we're going to do is to divide through by changing x. Divide through by changing x. So changing y divided by changing x equal to this will be negative changing x over x squared plus x changing x divided by changing x. Okay? So when rewriting, it will be changing y over changing x equal to negative changing x over x squared plus x changing x. This will now be times 1 over changing x. Alright. You can see that this will cancel out. We are going to have changing y equal to, alright, changing y over changing x equal to negative 1 over x squared plus x changing x. Now, take limit as changing x tends towards 0. We're going to have changing y over changing x. Limit as x tends towards 0. Limit as x tends towards 0. You can see it here. Limit as x tends towards 0 will give us negative 1 over x squared. Okay? Over what? X squared. Now, this will be plus x, changing x becomes 0. Hope you are getting what I mean. So x times this will be 0. We now have x squared. Finally, we have negative 1 over x squared, and this becomes our answer as we obtained before. So you can see the idea behind these two methods, general method and the first principle method of differentiation. If you're having any problem, do ask questions in the comment section. This brings us to the end of this class. Okay? And I want you to do me a favor, share this video, let it go viral, click on the bell icon for notification, and subscribe if you haven't done so. Thank you and be blessed. Bye.